Hello and welcome back to Summer Work Help for Calculus 1. In this video, we're going to be taking a look at question number 20. So for question 20, the directions say expand the log of 81 over 9x base 3 as much as possible. So this is probably going to be one of the shorter videos because this is just one question with just one part to it. So we have this logarithm that contains, it's a fraction and base 3 and things like that. So this is where we're going to end up using some of the properties of logarithms. And I guess since we have time, I'll go ahead and write them out over here. So some properties of logarithms that we're going to want to try to remember are, we've got the product rule. So if you have a product, so like the log of xy, so notice that xy is a product, it's multiplication with a base in a, with a base of a, rather. What you can do is you can split that up into two separate logarithms. And they both have the same original base of a. And what you can do is you can say that that's the logarithm of each factor, and then you add them together, right? It's the sum of the logarithms of the factors, right? You don't multiply them, okay? But when you have the log of a product, okay? When you have the log of a product, you are allowed to break them up into two kind of like smaller logarithms of each factor, same base, and then you can add those logarithms together, and that should be the same thing as the logarithm of your original product. So that's the product rule. There is also a quotient rule. Shouldn't really be that surprising, right? If there's something that happens with multiplication, then there's probably going to be something that happens with addition, or division rather. So when you have the log of a quotient, which is the result of division, x over y, base a, that again, you can split that up into two other logarithms, same base, but this time you're going to subtract the logarithms. So when you have the log of a quotient that is equal to the difference, right? Difference is the result of subtraction. It's the same as the difference of the logarithms of each factor, or of the numerator and the denominator, sorry. And then lastly, we have something called the power rule. So when you have the log with base a of something being raised to an exponent, that is equivalent to taking that exponent and sort of sliding it down in front of the logarithm as a coefficient. Like that. So y was an exponent on the argument going into the logarithm function, and you can rewrite that as taking that exponent and sort of putting it out front, just like you would with a coefficient. And these work in both directions, right? Equal sign does not just mean left to right; it also means right to left. Okay, so these are the properties of logarithms. If you forget them, you can always look them up, right? Properties of logarithms. They'll pop up as soon as you type it into any search engine or whatever. So these are the properties of logarithms that we're going to want to remember. So again, the directions here say expand the logarithm as much as possible. So there's a number of different ways to go about this. And actually, I solved this a little bit differently the first time. I'm going to do it a little bit differently now. Before you do anything else, you might want to notice, because I actually missed this at first, notice that the fraction, right, that can be simplified. So it says expand log, base 3 of 81 over 9x as much as possible. Well, the fraction is 81 over 9, and so 9x. That can be simplified to just simply, well, if you divide out a 9 from both the numerator and denominator, 81 divided by 9 is 9. And then 9 divided by 9 is 1, so it just goes away. So you're actually just left with the x there. So there's that. And again, I didn't notice that the first time I solved this problem. So you can, first of all, before you do anything else, you can just simplify the fraction. Then notice that what I have is I have a quotient. I have the log base 3 of 9 over x. Well, I have the quotient rule, which says that when I have the log of a quotient, I can break that up into two logarithms and find the difference. So this becomes log base 3 of my numerator, 9, minus, okay, we're subtracting because it's a quotient, okay? When you have the log of a quotient, you subtract your logarithms, minus the log of, or base 3 of x. So, I mean, kind of depending on how you look at this problem, I mean, you could almost say you're done, because it actually, this is about as expanded as it can possibly be. One thing I will point out, though, is you've got this term right here. You've got log of 9 base 3. So if you think about what this is saying, like log of 9 base 3, it's asking what is the exponent on 3 that gives you a 9. I'm going to say that one more time. It's asking you what is the exponent on 3 that would result in a 9. And if you express that in if you convert this to exponential form, well, it's saying your base is 3. You're going to raise that to something. I can't use x because I'm already using x, but I don't want to introduce a new variable, so I'm just going to say something. And that equals 9. So what is the exponent on 3 that when you plug it, when you evaluate that, you get a 9? Well, this works out very nicely to just 2. So the log of 9 base 3 equals 2 minus the log of x base 3. And that's actually how I would express my answer here. Okay. So it's expanded and simplified. Now the directions didn't say simplify, but it's also sort of like we kind of assume that we're simplifying. So this question is done. Now when you answered it, if you interpreted the question as like don't simplify and just sort of like express as much of this using as many logarithms as you possibly can, even if those logarithms can be simplified, then you might have a different answer. And like if that's your reasoning, like I get it. We'll probably change this problem for next year. But for now, for this year, this is definitely expanded and simplified. If you left additional terms in that are like additional logarithms, but you know they're just not simplified, and you left them in because the directions say expand but not simplify, then like I get it. You just want to be able to sort of use as many of these laws that we have over here on the right as possible. And we're going to use them again in the next question, 21 as well. So for 20, we're going to say final answer 2 minus the log of x base 3. If you did not simplify first, right, then you have to be careful because you do have a quotient, but then the 9x is also a product. So your denominator is itself a product, which means you can expand that. And then, yeah, can just kind of go from there. So question 20.